Hi, and welcome to the VEX studio. My name is Jason McKenna. I'm the Director of Global Educational Strategy for VEX Robotics, and it's my pleasure today to continue our series of interviews for Engineering Week. Today, it's my honor and pleasure to have the Dean of the School of Engineering, Math, and Science from Robert Morris University, my good friend, Dr. Maria Kalevitch. Here you can see right here with us. So, what better person to talk to about Engineering Week than the dean? But before we kind of dive into that, do you just want to talk a little bit about the School of Engineering, Math, and Science and a little bit about Robert Morris University by means of introduction to all the people watching us?
Well, hello, everyone. I will be happy to share with you that this year, Robert Morris University celebrated its centennial. So 100 years ago, we started as a school of accountancy, and now we are a four-year private university and located in Moon Township. And we have programs in healthcare, nursing, engineering, cybersecurity, data science, environmental science, biology, pre-medicine, you name it. So our School of Engineering, Mathematics, and Science is currently 22 years old. We started in 1999 with 22 students. And now we have about 700 students, with 400 of those students in engineering, and the rest are in sciences and mathematics. Each department has a nationally recognized program. For example, in engineering, it is certainly manufacturing engineering. This is the degree that is the only ABET accredited degree in the state of Pennsylvania. And we are well positioned in different initiatives that are proposed by presidents, like a tri-state initiative, America Makes, AIM with Carnegie Mellon University, or ARM Institute with Carnegie Mellon University, because we have a special emphasis on the workforce development and manufacturing, specifically additive manufacturing or 3D printing. So in case of mathematics, we have a designated center of excellence for our actuarial science program, and it's one of the leading centers nationwide. And our environmental science program in sciences department is recognized among 50 best programs in the nation. So really a lot to brag about, many things to share with you. But at this point, I guess getting back to you, Jason, and let's hear your questions.
Yeah, so just along those lines, of course, our vice president here, Tim Freeze, is also a graduate of Robert Morris University, and we just hired one of your recent graduates full time. So those of you that are using our VEX code programming language, Cole, who we hired from Robert Morris, is contributing to that as we speak, and we also have an intern, mechanical engineering intern, working with us right now. And we've been very pleased with what they've been able to do. So kind of a testament to your program and what you are doing there. It's been really great to be able to work with them. So, and your facilities are awesome. I got an opportunity to take a tour of your brand new facilities, and they're absolutely tremendous. But along those lines, as you know, Dean, I have a daughter. She's 17 years old. So we're going through that process right now of looking at schools and looking at colleges. And something that you see a lot all the time is, as a parent, is as I'm looking at different majors and different colleges, is what's going to be the return of my investment in a particular school. A report was recently published, actually August of last year, talking about how engineering has one of the highest, actually the highest rate of return for parents with the investment of their child's degree. But there's probably a lot of parents beyond, for example, mechanical and electrical engineering aren't that familiar with the engineering fields. So can you speak about that, just for a moment? And you kind of touched upon a lot of it there in your introduction to Robert Morris, of all the different fields of engineering that there are and the different things that students can pursue if they want to pursue engineering as a degree.
Well, absolutely. Certainly the best return on investment is in engineering, and no doubt, because the future workforce is in STEM and healthcare. And so in case of Robert Morris, we have degrees in software engineering, and that's what you mentioned about Tim. He graduated from our degree, from our major in software engineering. We also have a biomedical engineering, a very popular degree that also unites engineering with healthcare. And we have industrial engineering and mechanical engineering. And I mentioned already manufacturing, that is the only accredited in the state of Pennsylvania. So the important part is that we're very professionally focused, and we're making sure that our students who come to the university, we not only retain them, but help them to thrive and graduate in a timely fashion. And 92% of our students, 6 months or about a year after graduation, are employed in their field. And as you know, the starting pay for engineers are in mid 60s. So that's a great start, especially for those who graduate on time and do not accumulate debt, or at least minimum debt. So saying that, it puts really RMU as a special institution in a sense that it really cares about the student success. It cares when they are with us for 4 years, but also work closely with industry partners. You yourself mentioned about some relationships with alums.
Yeah.
So they are the ones who later become mentors to our students and open the doors for them to have internships and research projects. And that also, in part, opened the door for them for employment. So this is really a cycle and a process of on how we work closely with our students, faculty, alums, and staff to make sure that our students are successful. And that return on investment that you mentioned is valued and valuable.
And I think beyond the monetary investment, I think there's also the intellectual investment. So, what I mean by that is, with your own background, and you also mentioned biomedical engineering when you were going through different fields there. I kind of refer to this right now as the STEM moment, because if you think about everything that went into the development of the vaccines for the COVID virus and computational biology, which didn't exist 10 or 15 years ago. So how STEM has really impacted those fields. If you can just talk a moment about not only is engineering a great means to an end in terms of a job, but in terms of students' intellectual development, I can't think of a more fascinating field to get into right now than engineering and STEM.
Well, I'm extremely proud to say that as in March 2020, the doors of the university closed and we moved our classes virtually. Some of our students and faculty, certainly with social distancing and masking, remained on campus and worked on various projects with the University of Pittsburgh Medical Center, for example. And the reason why we worked on those projects, because our alums reached out to us from UPMC to make sure that we are involved in 3D printing face shields and also making nasal swabs. At that time, it was an extreme shortage of these materials. And so it was important to provide as many as we can to the community. And our students and faculty made absolutely sure that they participate and contribute. And I'm extremely proud of that effort. This is just one example. There are so many, and I'll be happy to share later.
No, that's terrific. That's quite awesome. And when we think about engineering, something and STEM in general, the thing that I really think about is innovation. So we talk about how engineers solve problems, and I know I work with engineers every single day, and I can attest to the fact that engineers do love to solve problems. There's no doubt about that. But I almost think that that's a little bit of curtailing what engineers actually do, because I really feel that a big part of engineering is innovation. So, for those students that are thinking about getting into engineering, and we hear that engineers solve problems, we do hear that a lot, but I would like for you to just touch upon this idea of innovation and how engineers can also be very innovative.
It's interesting that you mentioned that, because about 10 years ago, we in our School of Engineering, Mathematics, and Science created the Research and Outreach Center. And this center put a special emphasis on research projects with faculty and staff and opportunities for students to think out of the box and be innovative with various projects, whether that's an internal university project or the project that is related with industry needs. So on top of that, on the success of this SAMS Center for Research and Outreach, we now build the center, which is for the entire university, RMU Center for Innovation and Outreach. And the leading folks in that center is actually our engineering faculty, especially, and students, especially the ones that are interested in cross-disciplinary approaches. Because very often innovation teams, they are like design thinking teams that bring you their qualities and skills from different fields. In these teams, you have people with business background, you have people with engineering background, you have people with art background, and everyone brings something unique and different. With engineers leading that charge, it is important for them to always think out of the box. And yes, we bring the solutions, we make the decisions, but innovation doesn't have to be disruptive all the time. It could be an incremental innovation. It could be adjacent innovation. It could be some small process that is essential, but at the end will save a lot of money and effort and time for the company. So our students are always involved in this type of projects, and they are excited about opportunities to make a difference. So I also think that our engineers are not only innovative in thinking out of the box, they're the ones who always thinking about the impact and making a difference in the society and the community around, and that matters.
That's fascinating that you mentioned that. It reminds me of a book that I recently read. Gregory Zuckerman, who writes for the Wall Street Journal, wrote a book, The Shot That Saved the World, and it chronicled the development of the vaccine, as we mentioned before. And he talks about the fact that the vaccine was an overnight success that was 30 years in the making, because
Yeah.
he traced it back all the way to development of the AIDS vaccines, in the 80s. And actually had an opportunity to speak with Mr. Zuckerman, and he, as a reporter, someone that's not from a STEM background, he said one of his big takeaways from writing the book was that he learned in science there's no such thing as failure. There's just learning as a result of that. And I think that's something that we could do better K to 12 in schools, is this idea of iteration and learning from failure. And almost, failure has obviously a negative connotation to it, but kind of embracing that, right? In the design process, as you mentioned a moment ago, in the engineering design process itself, being able to optimize things, making them better, whether they're large innovations or small innovations, like you just mentioned, that's a very important point of it. So for our last question, if you just wouldn't mind talking a little bit about how the students, in an engineering program really, and also the teachers, embrace the idea of, embracing failure, learning from it, that iterative cycle that is so important to engineering.
Absolutely. In sciences and engineering, no is also an answer.
Yeah,
And that
great.
means you learn something and you go from there, and you do not repeat the mistakes again. So that's a learning process. So any type of failure that occurs, it's really a learning process. No wonder we often say by trial and error, because that's how we learn, and that's how we innovate, and that's how we improve things and make a difference. So I would actually embrace failure and never be afraid of it. The very executive person from General Electric recently mentioned to me that one of her employees came to her and said, I completely failed that project. And so when they started to talk about, really the person failed maybe only 20% of the project, but the 80% of the project was actually successful. So don't be afraid of partial success. Don't be afraid of failure. This is really part of the life and part of the learning process. And at the end of the day, we're all lifelong learners. And that's how we learn, by trial and error. That's what I would say.
No, that's terrific. And hopefully, if you're a student watching this video, some of the takeaways that you have from this in terms of engineering is obviously it's a great return on your investment, as the dean mentioned. But in terms of intellectually stimulating, being able to really explore really unique fields and do all types of different things, whether they're in fields of medicine, obviously fields of engineering themselves in terms of mechanical and electrical engineering, software engineering, as the dean mentioned. There's all different types of things that you can find that can fit whatever you're particularly interested in, and really kind of embracing the iterative cycle of having an idea, trying it, optimizing it. Those are all things that the dean talked about well, and those are all things that happen at Robert Morris University every single day. So thank you so much for coming and spending the time with us. I think there was a lot of great information that you can take away from you and learning about engineering and what engineering is doing every single day. And I can't thank you enough for spending the time sharing with the VEX students watching this video. Really appreciate it, Dean.
Absolutely, my pleasure, and welcome. Please come to RMU and see our new facilities. You will be fascinated to see how engineering, sciences, art, all are collaborative and interdisciplinary and cross-disciplinary, working together. And that's really an exciting opportunity for students to learn and better themselves and better the environment and community.
And that's a great
Thank you.
definition of STEM. So we'll go ahead and end it there. And thank you for your participation. Thank you for tuning in today at the VEX studio, and I'll see you again soon.
Bye.